Wormholes, the cosmic shortcuts. Imagine being able to travel from one part of the universe to another in the blink of an eye, bypassing light years of distance. This might sound like science fiction, but it's actually a theoretical possibility thanks to something called a wormhole. Today, we'll dive deep into the fascinating concept of wormholes and explore how they might just be the cosmic shortcuts we dream of. So what is a wormhole? A wormhole is essentially a tunnel or shortcut that connects two separate points in space and time. Imagine space as a flat sheet of paper. If you wanted to travel from one side of the paper to the other, you'd normally have to go across its surface. But what if you could bend the paper and make the 2 points touch? That's the idea behind a wormhole. It bridges two distant points, making the journey between them incredibly short. A wormhole can be thought of as a tunnel that allows you to bypass the regular distances in space. Instead of traveling from point A to point B across a long stretch of space, you can take a shortcut through the wormhole and arrive almost instantly. This concept, although highly theoretical, stems from Einstein's theory of general relativity. The science behind wormholes. The idea of wormholes comes from the equations of general relativity, formulated by Albert Einstein. This theory tells us that massive objects like stars and planets bend space and time around them. A wormhole would be an extreme form of this bending, creating a tunnel through the fabric of spacetime. Einstein's theory of general relativity describes how gravity is not just a force but a curvature in spacetime. Massive objects cause this curvature, and theoretically, it's possible to have regions where space-time curves in such a way that it creates a tunnel. This tunnel, or wormhole, connects two separate locations. Physicists John Wheeler and Robert Fuller later developed the concept, coining the term wormhole. Traversable versus non-traversable wormholes. There are two main types of wormholes, traversable and non-traversable. Traversable wormholes would theoretically allow you to pass through them safely, moving from one side to the other. Non-traversable wormholes, on the other hand, are unstable and could collapse if anything tried to travel through them. So far, most theories suggest that even if wormholes exist, they'd likely be non-traversable unless we find a way to stabilize them. A traversable wormhole is the type of shortcut that's often depicted in science fiction. A tunnel that you could safely enter and exit, making interstellar travel possible. However, the equations suggest that most wormholes, if they exist, would not be stable. They might collapse before anything could pass through. Scientists speculate that to keep a wormhole open, we'd need something called exotic matter, a form of matter that could counteract gravity and stabilize the tunnel. Exotic matter, the key to wormholes? One of the biggest challenges with making a traversable wormhole is stability. A wormhole, if it exists, would naturally want to collapse in on itself. To keep it open, scientists believe we'd need exotic matter, a hypothetical substance with negative energy. Unlike regular matter, which has positive mass and energy, exotic matter would repel instead of attract, potentially holding the wormhole open. Exotic matter isn't something we've discovered, but it's theoretically necessary to stabilize a wormhole. In general relativity, normal matter creates gravity, which would cause a wormhole to close. Exotic matter, with its unusual properties, could counteract this gravitational pull. However, the existence of such matter is purely speculative, and we currently have no evidence that it exists in nature. Time travel and wormholes. Wormholes don't just connect 2 points in space. They could also connect 2 points in time. This means that, in theory, a wormhole could allow for time travel. If one end of a wormhole is near a massive object or moving at a different speed than the other, time could pass differently on either side. Step through, and you might find yourself in the past or the future. The concept of time travel through wormholes arises from the idea of time dilation, where time passes at different rates depending on factors like gravity or speed. If one end of a wormhole is near a black hole or moving at high velocity, time could pass more slowly there compared to the other end. Entering one side of the wormhole could, in theory, transport you to a different time when you exit the other side. However, this idea raises many paradoxes and is purely speculative. Do wormholes really exist? As of now, wormholes remain a theoretical concept. We haven't found any direct evidence of them, and we don't know if they can actually exist in our universe. Scientists continue to explore the possibilities, searching for ways to detect signs of wormholes or figure out if they could ever be created. It's one of the most intriguing questions in modern physics. While the idea of wormholes is fascinating, it remains speculative. No physical evidence for wormholes has been discovered, and there are numerous theoretical obstacles to creating or detecting them. Scientists have proposed that if wormholes exist, they might create specific signatures, like unusual gravitational effects, that we could potentially observe. However, we're still far from confirming their existence. Wormholes in science fiction. Wormholes have captured the imagination of many storytellers, appearing in countless science fiction books, movies, and TV shows. From Interstellar to Stargate, these cosmic shortcuts make interstellar travel seem possible and exciting. While the real science is still catching up, the concept of wormholes continues to inspire new ideas about how we might explore the universe. Wormholes are a popular theme in science fiction because they offer a way to bypass the speed limits set by the laws of physics. While real-world physics may not yet allow for such shortcuts, the concept has allowed writers and filmmakers to explore stories of interstellar travel, time loops, and alternate dimensions, helping the public imagine new possibilities. The mystery of wormholes. Whether or not wormholes actually exist, they represent one of the most exciting possibilities in our quest to understand the universe. Could they be the key to faster-than-light travel, or are they just a mathematical curiosity? For now, wormholes remain a mystery, but it's one we're eager to unravel. Maybe someday, we'll find out if these cosmic shortcuts are real and whether we can use them to explore the stars. The conclusion summarizes the speculative yet exciting nature of wormholes. While they may just be a product of theoretical physics, they open up possibilities that could fundamentally change our understanding of the universe. The mention of future discoveries keeps the audience intrigued and hopeful about the potential for new breakthroughs. Thanks for joining us on this journey through the mysterious world of wormholes. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you don't miss our next adventure into the cosmos. Stay curious, and we'll see you in the next video.